Today we're going to be defining, oh, what color are y'all going to read? I forgot to remind you. What color are y'all going to read? Yellow. Yellow. Today we will define relation is that word. Let's try it. So we've got relation, function, determine, relations, plural, and functions, plural. Today we will define and function. I will determine if given are function. All right, and then you will have a Schoology assignment. It's not open yet, so I want to make sure you're paying attention. If I open it now, sometimes you'll try to get in and try to do it, and then you don't know what you're doing. Okay? All right, so Unit 2, Day 1, relations and functions. A relation is a connection between two sets of numbers. A relation is a connection between two sets of numbers.
Do you have a short film?
Do I what?
I have a short film.
There's one like this one right up there at the front, and there's a manual one back here. They can be expressed in a few ways. The first way we can express them is in a table. We can express them as ordered pairs. We can express them as graphs. And we can express them as mappings. We're going to look at all four of those today. Okay? So the first thing we're going to look at is tables. Your input, so when you work with functions or relations, you have inputs that produce outputs. Your inputs will always be the left column or the top row. It should say column or row. So the inputs will always be the left column or the top row. And your output will always be the right column or the bottom row. Okay, so when I look here, it says fill in the table with the relation that's in the table to the left. So my left column, those x values, that's going to be your top row if you turn the table horizontal. So that's going to all go there. So it's going to go x. Order is important because you still want your points to line up. So after the x will be a 1, and then a -2, and then a 4, and then a 0, and then a -2, and then a 5. So I'm just turning my table horizontal. That's all I'm doing. Because we need to be used to seeing them. We'll see them both ways. They give them to us on tests and quizzes and things, and on the STAR test, you'll see them both ways. Okay? And then your output is going to be your right column or your bottom row. So I'm going to transpose my y, my -4, my 5, my 3, my 0, my -3, my 4. And we do need to make sure that 1 is still matching up with the -4. And the 2 is still next to, the -2 is still next to the 5. The 4 is still next to the 3. The 0 is still next to the 0. The -2 is still next to the -3. And the 5 is still next to the -4. We can't rearrange the order. Okay? So those are the same table. They just look different, just the way they're built. Okay? The next way we might see a relation is as a set of ordered pairs. We're going to write our ordered pairs inside these fancy squiggly parentheses. Just do your best at drawing them. Mine aren't always pretty either. Okay? Each pair is going to be separated from the next with a comma. Write the relation from the tables above as a set of ordered pairs. So I re-put the table there just so we could refer back to it because it's not on my screen. So the first one we're going to start with is that cute little curly bracket. Just do your best to make that curly bracket. And then we're going to write each ordered pair. So a pair means how many? What is a pair? 2. 2 means a pair. So I'm looking for 2 values. I'm going to be looking for one x value with its matching y value. When we write them, this first one, 1 is going to go with -4. When we write them, we start with an open parentheses. We put our x value, we put a comma, we put our y value, and we close our parentheses. The parentheses are important. That's our first ordered pair. I'm going to put another comma because now I'm going to put the next one. The next one is going to be -2, 5. So same thing, parentheses, -2, comma, 5. Close that parentheses, and then we're going to put another comma because we're going to have the next one. Let's take our notes. You have a pencil. Let's take our notes. Open up your pen. Oh, that's not notes. You need to write them down. All right. 4, 3 is going to be the next one. Parentheses, 4, 4, comma 3, close your parentheses. And then another comma, what's the next one gonna be? 0, 0. And then a comma. Two more, the next one will be -2, -3. And then the last one will be 5, -4. They should all be in their own sets of parentheses, just normal parentheses. And then at the very end to say we're done, we're gonna put another one of those fancy parentheses at the end to say we're done with this set. This is everything in the set. There's nothing else in it. It's just these 6 points. Just these 6 points. Okay?
Got a little confused as to where we were.
Yeah, they're writing them in the wrong place, but that's okay. It's
But-
still in their notes, and that's what's important.
It's 4 different types.
Yes.
that they need to remember.
Yeah, we've moved down to the ordered pair area.
4 different types.
So the next type, so we looked at tables, we looked at ordered pairs. The next thing we're gonna look at is graphing them. Your graph, it says the input, so those x values, is the horizontal axis, and if you notice it's labeled with an x right there. And then your output is the vertical axis, those are gonna be my y's, notice there's a y right there. Graph the relation in the tables and the ordered pairs above. So we've already taken the table, we've turned it into ordered pairs, now we're gonna graph them. Okay, so if I want to graph that first one, 1, -4, it's at an x value of 1 and a y value of -4. So if you look up at the screen, if I start from my origin at 0, 0, everything's 0. My x value is 1, so if I think about where 1 is on the x-axis, and my y value is -4. So if I look at that y value, I'm going to go down equivalent to where that -4 is. So that has an x value of 1 and a y value of -4. My next point is -2, 5. So if I start there at the origin, my x value is -2. So if I look at where -2 is on the x-axis, and then from there, I'm going to go up where it's equivalent with the 5 on the y-axis. My third point is at 4, 3. So I'm going to start at the origin. And 4, I'm going to go to where the 4 is on the x-axis. And then I'm going to go equivalent to where the 3 is on the y-axis. 3 more, the next one's 0, 0. That means I'm not going to go left or right at all because I'm already at 0 on the x-axis. I'm also not going to go up or down at all. I'm already at 0 on the x-axis. Does anybody remember what that point is called? Origin, very good. Alright, so then the next one, -2, -3, if I start at the origin, I'm going to go -2 on the x-axis, and then I'm going to go down to -3 equivalent with the y-axis. And the last one, 5, -4, if I start at the center, I'm going to go on the x-axis to where 5 is, and then from there I'm going to go to -4, so I'm going to go equivalent down to -4. That's what my graph should look like. We should have all 6 points graphed. Okay? Alright, so that's graphs. So we looked at tables, we looked at ordered pairs, we looked at graphs. The next thing we're going to look at is mappings. Mapping is just a visual representation of which output value the input value produces. Okay? Fill in the mapping with the relation in the tables above. Remember, your inputs are your x values, and generally, it's not required, but generally we'll do them from smallest to biggest, and if they repeat, you don't have to rewrite them. Okay? So, my smallest x values are going to start on the left. So I'm going to look at the points that are farthest to the left. What's that x value for those 2 points? -2. So I'm going to start with -2. And then I'm going to travel from there to the right. The next point I hit is that one right there at the origin. What's that x value? 0. And then I'm going to travel to the right. The next one I'm going to hit is that blue one down at the bottom. What's its x value? 1. Travel to the right. The next one I hit, what's its x value?
4.
4. And then the last one, what's its x value? 5. So those are all my inputs. Now I need to figure out what all my outputs are. My outputs are my y values. So again, this time I'm going to start small to big. Small on the y-axis is going to be down low. So the lowest I go. What's that lowest value? Negative 4. The next lowest as I travel up, the next one I reach is negative 3. The next one is 0, followed by 3. And then last but not least, 5. So those are my inputs and my outputs. Now, the point of the mapping is it tells you where does that negative 2 go? Where does the 0 go? Where does the 1 go? Where does the 4 go? Where does the 5 go? What does it produce? Okay? So when I look at my points, I know that 1 is supposed to go to negative 4. So here's how we show that. 1, we draw a line between 1 and negative 4. Then from negative 2, we draw a line to 5. This one now. Keep your head up. I'm going to see you right here, unless you're taking notes. Okay. The next one, 4 is going to go. We're going to draw a line from 4 to 3. What's the next line we're going to draw? 0 to 0. The next line? Negative 2 to negative 3. Notice we already had one coming out of negative 2. That's okay. And then the last one from 5 to negative 4. Notice I have 2 going to negative 4. That's also okay. That is what a mapping looks like. I can see that negative 2 goes to both negative 3 and 5. 0 goes to 0. 1 goes to negative 4. 4 goes to 3. And 5 goes to negative 4. Okay? So we've seen tables. We've seen ordered pairs, we've seen graphs, we've seen mapping. Those are the 4 different things we're going to look at. Now, if I look at my objective, you're going to read what color? Don't pick it up. Absolutely not. Pick it up. Today we will define and I will, if given, are. Very good. Remember, we are going to have a Schoology assignment today. And you're going to get to come sit next to me and work on it. Yeah. Alright, an important relation we didn't talk about. It says today we're going to define relation. Done. We did that. We haven't done function yet. So we're going to work with that next. A function is a relation where every input has exactly one output. Every input has exactly one output. The inputs cannot repeat with different outputs. It only gets one. It only gets one. Okay? So if I look back at that mapping that I had just done, let me get there. Notice this input right here has 2 outputs. It goes to negative 3 and it goes to 5. This is not a function. It's just a relation. It's not a function. Okay? A function can't have 2 lines coming from one input. Okay? Only one output. Your inputs cannot repeat. So it says, are the following tables functions? I didn't get those animated, that's okay. Look at the first one right here. All we really worry about are my inputs. They cannot repeat and go to different things. Are all my inputs different?
Yes.
Yes, so 1 only goes to 5, 2 only goes to 6, 3 only goes to 7, 4 only goes to 8. Yes, that is a function. Okay? What about this next one? No, because negative 1 can't go to 9 and then also go to 10. So this one is not a function. What about the third one? No, for the same reason except even one more, right? Negative 2 is going to lots of things. So that one's not a function. What about the last one?
Yes.
Yes, very good. That one is a function. 3, 4, 8, 9, they're all different. So yes, no, no, yes. So that's how we look at a table. All you have to do is look at either the first column if it's up and down like this, or if it was a side-to-side table, you just look at the top row. Okay? Are the following sets of ordered pairs functions? So when I look at this one, remember the input cannot repeat. So my inputs are the first number in each ordered pair. So the 0, the 1, the 3, the 7, is this a function?
Yes.
Yes, we don't care what the y's are doing. What about this one?
Yes.
Yeah, 1, 3, 5, 7, we're good. What about this one?
No.
No. What about this one? Yes. I'm gonna add that comma in there, I was missing the comma on your note sheet. Alright, just keep in mind when you have 4 like this and one of them is no, a lot of the times on the tests, you'll see questions that are kind of tricky. A good test taking strategy or test taking tip, this would be a good type of multiple choice question where the question is which of the following is not a function. You really do have to read your questions because sometimes they have that word not, and if you don't pay attention to it, you're just used to finding things that are what you're looking for, and you go, oh, the first one's right, it's a function. And you'd say that's the answer and move on because you found the function. But this one's saying which one's not the function, so you have to look for the one that's not, okay? So watch out for that word when you're doing anything that's multiple choice, that you're finding the one, that you're reading for that word not. Okay, in which case our answer would be that second one. Alright, are the following mappings functions? So we're gonna do the same thing, we're gonna look. Negative 19 only goes to one value. Negative 14 only goes to one value. Negative 11 only goes to one value. But what about that negative 9? Yeah, it's going to 2 things. Is that a function?
No.
No, I don't even have to finish looking at it. What about this one here? Is this one a function?
Yes.
Yes. Each one only has one line that leaves it. What about the last one?
Yes.
Yes. So the only one that wasn't was the first one. It has 2 lines. Notice here, it doesn't matter if more than one thing goes to this 14, or more than one thing goes to the 17, or more than one thing goes to this 19. The right-hand side we don't worry about. It's the left-hand side for being a function. Okay? Alright, when we're graphing, so we looked at it on the table, just look at your x values, we looked at it as ordered pairs, we looked at it as the mapping. Okay? Now we're going to look at a graph, how that works. We use a test called the vertical line test. Which direction is vertical? Is it side to side or up and down? Up and down. Vertical is up and down. Okay? We're going to use a vertical line test, and what that says is if you can draw any vertical line that intersects the relation more than once, then the relation is not a function. If you can draw any vertical line that intersects the relation more than once, the relation is not a function. Okay? So if you look up at the screen, I have this graph right here, and watch what I'm going to do with my vertical line. I'm going to take that vertical line, I'm going to see, does it intersect this more than once? So there's my vertical line. It's going to go from left to right, and you're going to see, does it make more than one point everywhere it travels? Is there ever more than just one place it touches that graph? Did it ever touch more than once? No, everywhere that red line goes, it only has one red dot associated with that graph. So that one is a function. Okay? This next one, if I look at a line, I go from left to right. This one I couldn't get my dot to line up as well. It's not as pretty as the last one, but oops. Yeah, y'all saw. But watch the dot. Does the dot ever hit more than once as it goes across? No, right? So that one's also a yes. It passes my vertical line test. What about this one? No? Let's see. Watch my graph. It doesn't touch it at all yet. Oh, but there it touched it. Oh, wait, did y'all see that? You want to see it again? We're going to see it again because I spent a lot of time on this slide. It took me forever to get those dots to look.
Yeah, I was like, how'd you
even
do that?
halfway. Oh, it was a lot of trial and error. It looks better than I thought it did at like midnight last night.
If it's just a straight line.
So this one is a no because this point right here and on either side just a little bit, there are definitely those 2 spots where it fails the vertical line test. You can only touch one time. So if you can anywhere on the graph draw a line through it and hit that graph more than once, it's a no. Okay. All right, let's look at our objective for today. Today we will define and I will if given are, so we did define relations, right? And there, we can see it as a table, we can see it as a graph, we can see it as a mapping, we can see it as ordered pairs. And then we can determine if those are function or not by looking at those x values or those input values and making sure they don't repeat or go to more than one place. Okay? Alright, so Unit 2, Day 1, Relations and Functions. I'm gonna open up that Schoology assignment. Okay? These are your notes. You're gonna wanna either, if you're gonna wanna keep them so you can use them to do your Schoology assignment. If you don't finish it class, you can do that. Or I'm gonna try to find a crate, and if you wanna keep them in the crate, you can keep them in the crate as well. That way you don't have to worry about losing them.
They all have holes.
And you have folders somewhere. I'm gonna open your Schoology assignment right now. Everybody should get in it. You have time to finish it. And then you don't have homework. Do you need a cord? Oh, you have one? Okay.